Hello, everyone. It is a great honor to be a presenter at this conference hosted by the Helsinki Center for Digital Humanities. This center is the most successful and innovative center and the leader in the new digital age. The DH Summit encourages us to share the experiences of the results of today while aiming at the visions for tomorrow. Here, I will try to present the rationale of semantic enrichment for enhancing historical and cultural heritage data to support digital humanities research. I know that many of you are already experts in doing the semantic enrichment. Here in my talk, I will share my personal experiences and the vision in terms of why and where we need to address the semantic enrichment in the context of libraries, archive, museum data. Among the approaches, the second big part, the semi-structured and the unstructured data will be the major discussion point. With the rapid development of the DH field, demands for historical and cultural heritage data to be used in both big data and smart data projects have sharply increased. The digging into data challenge is a good example showing the demands for historical and cultural heritage data in DH research. This is since 2009, through this program, 18 research funders from more than 10 countries have funded thousands of projects aimed at research questions in the humanities and or social sciences. Based on the project descriptions of the last 4 rounds, I compiled a list showing the domains and areas of interest, resources, and approaches. I'd like to bring the attention to the resources, which includes mainly unstructured data sets. Those could be originated in ancient times, or there are also structured data sets created in the digital age and that can be used. These primary data resources are usually served through libraries, archive, museums, and other heritage institutions. Those data, a lot of them are unstructured data found in documents and other information-bearing objects. You won't be able to grab from the web or using real-time streams and mobile analytics. The LAMP data processing in the semantic web could be considered in 3 stages, starting from digitization of unstructured data. That during the last 2 decades, many digital collections were born in LAMPs and have exhibited strong outcomes. The creation of those digital products involved a very complicated digitization and documentation process, requiring tremendous investments from government and other institutions. But just digitizing is not the end product. The LAMs are dedicated to transforming the unstructured data into structured data. Data in the humanities is big or smart or clean or messy. This is the earliest article that brings the smart data concept into digital humanities, indicating why data has to be cleaned, how that the unstructured, semi-structured, and structured data are turned into smart data that reflect the research priorities of a particular discipline or field. And more importantly, smart data inquiries can then be used to provide comprehensive analysis and generate new products and services. Is smart data. You all know big data that has been characterized by multiple V's. The realization of the last V, value, is dependent on smart data. The smart data means the ability to achieve big insights from trusted, contextualized, relevant, cognitive, predictive, and consumable data at any scale, great or small. Among this, the contextualization is one of the major points of semantic enrichment. Next, we will use a framework to discuss the approaches used in the semantic enrichment of LAM data. The first one will be very short, then the emphasis will be on the second and the third. All kinds of data resources provided by LAMs and other heritage institutions. They can be categorized in three main groups based on their type: structured, semi-structured, and unstructured. Here, I will first start with the structured data. The enriching structured data, often referring to metadata, has become a common strategy used by the LAMs. And I use Europeana's explanation about this enrichment could be a process and could be a result. And in the literature, you see several other terms are popularly used. In this section, we'll have a starting point that all the existing metadata components that are in a controlled form. And looking at the examples, first is the contextualization. This is what Europeana has done. And you can see that create typed relationship between resources of different types that usually the automatic linking method is the effective one applied to those fields that are in a controlled form. So the pattern, you can see that several enriched areas or entities is showing here. And the most recent November 2020 process again enriched meanings of the entities that are in the controlled form. Each institution can also enrich their data. A unique named entity-centered case is the information cluster on website of the Museum of Modern Art, MoMA, in New York City. By using the tool often refined for consolidation, thousands artists in the MoMA dataset obtained HTTP URIs and Getty records from ULAN. Very smart. Now in the front end, you can see the Getty record brings lots of important information and multilingual names. At the back end, the artist URIs from Wikidata and ULAN are embedded now in the head section of the HTML page, coded with schema.org properties, same as. After enrichment, the results on the web is significant. This is searching by using Bing on the left side with last year's results that MoMA already are on the very top. And this year, because the Microsoft Knowledge Graph that I showed in the middle, it's now supporting Bing, the result is even more positive. The searching brought the artist's Wikipedia pages in all languages, the museums hosting the artist's works, and libraries that have books about the artists, and many more, as long as they map the ULAN ID. This example is from faceted application of subject terminology of OCOC that connect the particular entry, here is a JFK, to the real things about JFK, not just the name of JFK. Let's go to the other links. So the JFK entry in FAST is enriched with other sources because it uses correct coding of properties. And you can see that it comes to the FOF focus. Using this, the FAST control terms is related to a real-world entity and allows human to gather more information about the entity that is being described. I've talked about those additional nodes for those massage situation or contextualization, because there could be different decision point, such as if your original data sets has used the local control vocabularies. If it has used a pre-LOD linked open data vocabulary. And also, if you want to make a decision to map which vocabulary and how many will you bring that in, because in the subject domain there may be more than one standard vocabulary. And if it needs to map to a standardized, not local, a standardized linked open data vocabulary, then how much human resources and quality control will you be able to ensure? And also maybe the standard vocabularies is not enough. So what other special vocabularies do we need? If a data set's starting from local through all this and then goes through aggregation, there are also issues of the control of synonyms, acronyms, because everyone uses different way. The second part will look into the semantic enrichment for semi-structured data. In the previous section, I will talk about structured data. But what about those uncontrolled, not normalized, and the free text part within metadata records, or the unstructured segments of otherwise structured data sets? An important feature of semi-structured data resources that should be recognized actually resides in their nature of being the products of information processing. So they represent the accumulated time, knowledge, and the experiences of the creators who generated those metadata. With the semantic enrichment process, the data values in those data are contextualized through the metadata element fields, so the function and meaning are clearly implied. Let's have some examples. We'll have some cases showing where are those semi-structured data exist. This is a demo of the MARC records, which contains unstructured nodes. I highlight some entities inside of those 500 fields, which are now just in the natural language in the nodes field. So there is a project in OCOC mining MARC's hidden treasures. Initial investigations into how nodes of the past might shape our future. So they have experimented with parsing the data in order to associate the performers' names with authority data and then identify role terms and the phrases with control vocabularies. And this has been very fruitful. You can see that huge amount of data involved. Finding aids provide contextual information to understand the nature and the scope of archival collections. The format of the genre is mainly semi-structured, characterized by large text boxes in which many types of information or entities are just unlabeled and exist in those descriptions. So the text from the archival finding aids in the description information, there could be scope notes, content notes, and detailed description of the contents, including many boxes, folders, and the item titles. There are also abstracts from these descriptions. So the genre is mainly semi-structured. So inspired by the possible semantic enrichment technology for entity analysis and extraction, and also the potential of using the linked data principle to enhance the discoverability and the linkability of the rich information in finding aids. And our team has a big project conducted and using the sample of 43 archival record groups. The finding aids are from 16 institutions in the country, in the USA. So the research team developed a program to allow batch processing. The software automatically obtained the archival records and sent them to the semantic analysis service supported by OpenCalais. and there are different output and double quality control using other tools. This example demonstrates how this is working. Using the Open Calais demo tool, the semi-structured data parts is put into the box there and submit. Very quickly, the results come back with the highlighted entities. On the left side are different types of entities that extracted. The analysis results in dozens and at times hundreds of potential entities. But what about the quality? Do you trust using those kind of free demo version? We found that, for example, the mostly correctly identified entities are personal names, corporate names, geographical names, and events. And there are some scores which show you how important or how relevant. But the social tech or industry terms and products, those categories are least reliable because those free sources do not have a knowledge base behind about the archives that we are processing, mostly heritage and cultural thing. So that part is not the most accurate. So do we use that to do this? We think that it would be very good idea to experiment with the semantic analysis methods. This could be your initial step to suggest the key entities and topics. Or you can wait till the final as a final check to ensure that important concepts or entities have not been overlooked. For certain types of record, particularly those which subject indexing is not common, semantic analysis may provide entity points, like those events, to archival records that were not previously available. And such techniques will enhance subject analysis at the first two levels, what we call that description and identification, but are unlikely to be useful for interpretation or subject of the material. Could the entity extraction be useful for special collections and other things that are not marked, not archival finding aids? I did a few more testing and then we'll show you the examples. Another testing at my team was on the thesis and dissertations because those are usually not cataloged by a library. Subject headings are not common in those records. So the research findings that we did around 44 philosophy theses manually checked by a student who has both philosophy and the MLIS master degree to see the relevance of semantic analysis using the tool of Open Calais. The research findings from the sample based on these abstracts generated more successful texts than those based on the titles. A very interesting and successful finding. When your digital collection is from hundreds of photographs, And they also lead to the research and development products. How could semantic enrichment help? I'm using the Getty Research Institute special collection as my example. This is a photograph collections record. You see that the physical description is in 915 boxes. The subject terms including one called Cities and Towns Italy. But what are the cities and towns? Could this summary parts help us to find out? Can we enrich this part of the semi-structured data? Now, using enrichment, before that, there is one heading about that place. After 3 seconds, I have got all newly generated place names from this paragraph. This is another tool we used. I used it also for the finding aids. Here, just demo that how this one come up. This is another tool called Congenital Intelligence API. It's a real intelligence service use. So I checked another photograph collection, History of Photography in China. It's also hosted by the Getty Research Institute. Just for places, it's immediately, you can see on the top all the kind of functions. Get the place as well as the maps. The tool also provides, it's called write print analysis, which estimate the readability level of a provided document, collecting the full set of readability indexes as well as about the grammar, about lexical and semantic analysis scores. Captions and other informative descriptions for cultural objects featured on the individual web pages of a museum could benefit from entity extraction as well. On the top, you can see this is an example about the legacy vase in Yuan Dynasty, carrying the stories of 4 ancients and their favorites. This semantic analysis tool, Zeng, was able to extract the 4 names as well as the things they love. The English caption were also easily used to be recognized by these 2 tools that I mentioned before. So here are some of the semantic analysis fact mining tools. The first 2 are used in the testing very frequently. One thing that remembers the Congenital Intelligence API represented that they are taxonomy and ontology supported with machine learning and natural language processing behind it. So the takeaway so far means this semantic analysis as a advanced semantic enrichment method has been used and can be used for analyzing, searching, and presenting information by using explicit semantic relationships between known entities. Yeah. And I mentioned that they have been supported by taxonomies, ontologies, and also benefit from machine learning and the new artificial intelligence technologies far beyond normal natural language processing. On top of the rule-based systems, the embedded based system for knowledge graph completion has become a new and a more popular way to do the research and development during the recent years. The examples revealed that all this you can do this kind of work for large digital collections, as well as for individual item-centered information clusters. You can do case by case, top-down or bottom-up, collectively or independently, with or without significant project funding. And also a benefit is that aggregation can be based on the pieces and chunks of information one needs from a dataset without integrating a whole database or converting full metadata records. We've seen this at the beginning of this section. It really makes sense, right? Why use data from semi-structured data resources? And also the last point is that by passing those data through advanced information technologies, these LAM data are dramatically enriched and are converted into new access points. This section will be about information discovery and rediscovery from unstructured data through semantic enrichment. Unstructured data can be found in documents and other information objects. They could be textual or non-textual, digitized or non-digitized, and may exist in any and all kinds of formats. Have seen this one brought at the beginning, that those unstructured data found in the documents and other information-bearing objects are available in the largest quantity, have the most diversity in type, nature, and quality, and are the most challenging to process, and no one can grab them from the web. It's all provided by LAMs. I will use several examples to show the new structured data generated from unstructured data to support knowledge discovery. And those are content-based, semantic-based, instead of word-based. You probably all know this linked JAS project, which is a pioneer linked open data project and has the transcripts of oral history interviews from 5 archives, over 50 such, and they are powered by the OCR and natural language processing. After processing that, they were able to choose and control the synonyms, eliminate ambiguity. You know, you're in the oral history interview, people mention he or she and I, right? Or you have to find out what kind of entity here and what relationships here. Then map to the authority-controlled vocabularies under the DBpedia. Then generate testing and annotating. Then the relationships have to be presented through an ontology. Finally, a visualization tool was used to show all of this. This great project was recognized by music community and gave the award. Another important part and step is this one also inspired and used by Carnegie Hall project, which is a tremendous step ahead. Beyond the text-based, the word-based, there are also lots of images. You all know that IIIF, the International Image Interoperability Framework, has 4 APIs, which are very, very useful for annotation and for content retrieval. This is a digital humanities platform to study the Chinese ancient wooden clips and then characters written on them. The written characters are living cultural evidence tracing back to the Han Dynasty. Images of objects and characters can be annotated under different motivations and subtypes. Very helpful to the reusability of scholarly needed data. In cooperation with 6 research institutes in Japan, an API for sharing query results was developed to enable query of a single character across different databases. There are endless showcases of the successful use of IIIF APIs. A little bit more complicated is the map. So the MapHub is a historical map annotation portal. It supports multilingual searching. So I did my search and found a map. This is my example. Once I started annotate these 8 banners in Beijing, it automatically pop up the annotation tools as well as the suggestions. But the most interesting thing to me is that after you did 3 points annotation, you can actually get the map showing what they call the overlays with the current Google Map or Google Earth. This means you contextualize the georeferencing, you reveal history through map overlays. The Dunhuang Mughal cave can trace back to the 4th century. It's also known as caves of the 1,000 Buddhas. Very rich content because also depicting various aspects of the medieval politics, economics, culture, arts, religion, ethnic relations, and daily dress in the Western China. The rich contents of this Dunhuang cave get very, very challenging. You say, what this image tells you? What are the stories? Who is there? Right? Just a simple thing? Well, much more than that. For example, this is a Wutai mountain map. It's located in one of the caves and very, very large, very long. After digitization, how can we do the annotation? Is this treated as an ancient map? Yes, it is really a map showing the mountain area. Is this a narrative painting? Yeah, there are stories inside. It's a figure painting? Of course, there's certain Buddha there. So the moral is not only a typical image rich in semantics, but also very comprehensive embodiment of the cultural heritage there. This picture shows that they have done the moral content annotation in a lot of details. The important thing is that if you want to deal with this, for example, different Buddha, you have to have a name authority for that. If it's a story, you have the control of all the entities. So it's a related project that Dunhuang Moral Thesaurus created for this purpose. And then the annotation, when you index or annotate a particular thing, you type and establish that thesaurus, which is SCOS supported. And this can be used for the contextualization and re-storytelling. The next example is for cultural objects. And this is a well-known online coins of Roman Empire OCRE project. You probably heard about this from the Lord Lamb and other event. I want to just show the revolutionary or pilot that they have designed to help the identification, cataloging, and the research of the rich and various Roman Empire coins here. I want to highlight its way of showing all this with ontology-based support at the end. For example, instead of just browsing, searching, you can also look by maps, look by the symbols, and identify a coin in a detail. But that's not enough. You can do other visual queries. This is to visualize the query on the fly. And for people in the humanities who is not familiar with Sparkle query, not familiar with statistics, you can just simply use this to bring your queries and visualize the results on the fly. It's really a smart data approach. Not only give people adequate, sufficient number of relevant information, but also provide users with the data and enable the quantitative method of inquiry. And for example, by comparison the components of the silver, gold in the coins and compare the particular time period of emperors, it can show the status of that time. That's why it was used by researchers for history and economics and policies, and all great findings. There are also intangible cultural heritage. What can you do to enrich the information of this? And led by Professor Sujimoto, the intangible cultural heritage was studied for how you use digital archives, documenting them, and enrich by showing the skill, the knowledge, and the community memory in this. The digital archives brought bigger project, and it's called digital archives modeling. There's several projects there, but the common research goal is enrich values of digital archives, right? So by how you do that, metadata aggregation. There are many other notable projects by the LAMs. You might follow many different kind of them, and here just examples based on their special focus, based on how they were able to bring incredibly amazing resources from unstructured data turn into contextualized, meaningful data. The last one is the most recently launched platform. I would highly recommend you take a look at that. They use the linked art model. And also the related one for the Van Gogh letters is just amazing. You can see all this way of what we understand as enriched for all these heritage and historical resources. So it's time to do a summary and conclusion. The advanced semantic technology today now allow the researchers to access and reuse large volume of diverse data. This is all the example shows this, and the potential for researchers to use and for their outcomes are endless, great potentials. So enhance the historical and cultural heritage data to support the digital humanity research. This have some way we demonstrated like enhancing subject access, and that also transforming the semi-structured and unstructured data into structured data through semantic analysis, then align with the control vocabularies. Linking and contextualization enable one-to-many usages of LAM data. So this kind of smart data approach in digital humanities can be seen as transforming unstructured data to structured data. And the trending is not just put machine readable data there, it's machine understandable, machine actionable data. They are accurate, they are used in the interlinking, citing, transferring, rights, permission, use, and reuse. So there are one-to-many uses and high efficiency processing data. I've showed a lot of results of today, and this also gives us the vision for tomorrow. Just like your center highlighted from 5-star to 7-star. What we are producing is from data silos, and then make data lakes like a repository, and then generating data planets in different planets, and finally get into the data universe. The sample model and sample framework has been the pioneer and leader in the world. I think if we can implement all the semantic enrichment strategies into any data we are handling, in the way top-down or bottom-up, we may be able to enhance and provide more meaningful and fairness LAM data, the cultural and historical data to support digital humanities. And thank you for listening to my long talk. Here are the inspiring references, including a lot from your center. And here are the more references that I used in the presentation. You probably can find a lot more in the Digital Humanities Conference. Thank you again.